Alright gang, here we go. First video in my new series, Chem 1. So this is Unit 1, Chapter 1. I'm recording it for all you Spring Hill High School folks taking Chem 1 from me and other teachers. Okay, so this goes along with your note packet. If you're not from Spring Hill High School and you happen to be watching this, welcome to chemistry. Alright, so Unit 1, Chapter 1, Intro to Chemistry. The first bit of this is going to be pretty simple. Okay, chemistry is the study of matter and the changes it undergoes. Yeah? So we're just talking about matter. Well, what is matter? Well, matter is anything that has mass and takes up space. So remember, mass is not the same as weight, right? This does not equal weight, okay? Because remember, if you weigh yourself on Earth versus weighing yourself on the moon, you're going to weigh different things. Okay, so remember, your mass is really a measurement of how much energy it takes to move you. Okay, so take physics next year if you're interested in learning more about that. Okay, and it also has to take up space. All right, so that means it has to have some sort of volume, right? Okay, so we're talking about in chemistry, it's the study of the matter, so things that have weight and have some sort of substance to it and then take up space, and how it can change from one thing to another. This all started with the idea of alchemy, this ancient idea that they were trying to convert one element to another element. Specifically, they were trying to make gold. Okay, so some examples of things that have mass, so the pencil that you're holding right now if you're taking notes, or the chair that you're sitting in, or the computer you're watching this from, etc. Those all have, those are all matter. Okay, things that are not matter, like, well, the big example of not matter is energy. Okay, now this is kind of debatable, but for the most part, it's define that energy doesn't have matter to it. Okay, it doesn't have mass in the traditional sense. Okay, and then we also have things like your thoughts and your feelings. Those don't have matter. Okay, all right, all right, cool. So that's kind of what chemistry is. That's what it's all about. So we got lots of different branches of chemistry. We've got organic chemistry, and it's the study of chemistry that has carbon in it, so carbon-containing compounds. So all these organic molecules we talk about, methane, propane, butane, all those are really essentially just carbon atoms just stuck together. Inorganic chemistry is the study of all the other substances, so the ones that are not containing a plethora of carbon. Okay, some of them do have organic fragments bonded to it. So you have like metals that are bonded to, or you have organic materials bonded to metals, and in that case, that's still considered inorganic chemistry. For the most part, high school chemistry kind of focuses on this, so this is kind of our wheelhouse for the year. All right, physical chemistry is a really interesting topic of chemistry, and it's the study of like the properties and changes of matter and how they relate to energy. So when you start talking about quantum mechanics and things like that, and really deep thermodynamics within chemistry, that's all the branch of physical chemistry. Analytical chemistry is kind of like the chemistry that you see going on in CSI type shows. So if they're analyzing the blood of some victim to see what kind of drugs they had in their system and stuff like that, that's all analytical chemistry. Biochemistry, if you took biology and you learned about photosynthesis and the Krebs cycle and all that stuff, then that's all biochemistry stuff. It obviously gets more complicated than that. And then theoretical chemistry. This is chemistry that we have theories about, but we haven't quite developed the machines to do direct measuring. So we use computers and mathematics to model what we think is going on. Okay. So now we got to jump to scientific method. All right, so most of you guys should be very, very familiar with what the scientific method is. So specifically, you always start with making observations. You make your observations, think about what's going on in the real world, look at what's happening, take some notes, develop some questions and some problems with it, and then you'll make your hypothesis, which is an educated guess, and you guys should all be used to making hypotheses and understanding what they're about. Okay, then the tricky part is, and this is really where chemistry is going to start to differ from other science classes you've had in the past, is that we're really really going to focus on what it takes to make an experiment to test that hypothesis. Okay, and we want to be able to test it many times, and we want to be able to test it and then take those ideas and test it somewhere else, or have somebody else even run the experiment for us. All right, so there's different parts of our experiment that we always need to consider. Okay, so the first one is the control, and so this is the sample that remains the same. So specifically, the control is the thing. So you're looking at something, and you're going to change something about it to test what happens. You need to keep a control, so something that you haven't changed, so that you can compare it to the thing you're experimenting on. All right. So the control is the thing that you're leaving the same, the sample that's remaining exactly the same. All right. Your constant. Okay, your constants are the things about your experiment that are remaining the same, that you're not changing. Okay, now that's different than your control, because your control is the thing that you're measuring, or the object that you're measuring, and then your constants are the things that are kind of affecting it. All right. Then you have your independent and your dependent variables. Your independent variable is the thing that you're changing, and then the dependent variable is the thing that you're measuring. All right, and all of this will hopefully make sense here in a minute when we're going to design our own experiment real quick. All right, and then after you run your experiment, you go it a couple times, you check your data, okay, do some analysis, and you decide if you're going to reject or change your hypotheses. All right, so example of experiment. So let's say we've noticed that some students do really well on exams and some students do not do well on exams. So if we say, let's say we think that our hypothesis is that if a student studies more, then their grades will go up. All right, so that's our hypothesis. So we've noticed that some students do better than others, so we want to see if studying more will make our grades go up. All right, so the first thing we need to find is our control. Now remember, our control is the thing that we're going to use to compare. All right, so in this case, according to our hypothesis, we've got students, or a student, that we want to change. And so this is kind of where you have freedom as a scientist to kind of decide where you want to go. Do you want to test the same student over like 2 different times, once where you've changed the amount of time they're studying and once where you've not, or do you want to do it with a group of students? So we could say, well, we're going to take a sample of 5 students, and we're just going to let them continue to do what they've saying unchanged. So we're not going to change their study habits. Okay? So these are the 5 students that we're just going to let chill and do their own thing. All right? Then the next thing we need to come up with is our constants, right? So the constants are the things that need to remain the same between your control group and your tested group. All right? So your constants, well, there's several things we need to make sure are constant here. We need to make sure that all students are in the same classes, or in the same class, right? All students in the same class. We need to make sure they're given the same tests. We should probably make sure that they're kind of like equal in academic ability, okay? Because that could throw off our experiment. Etc. So those are the kind of things that you're looking at for your constant. All right, and then we have our independent and dependent variable. So our independent variable, remember, that's the thing that we're changing. Okay, so we said that if the student studies more, then their grades go up. So the independent variable, we could say, well, we're going to measure that the hours they spend studying. Okay. So this is the thing that we're specifically changing. And then the dependent variable would be the thing that we're measuring, right? So what are we measuring? Well, we're measuring their grades, right? So we're just going to measure it based on how they do. Okay. Then once our experiment's done, we can say, all right, well, these 5 students, they just studied however much they're used to studying, and then the 5 students we tested, we can measure how much they we can set, like, well, you're allowed to study 2 hours, you're allowed to study 4, 6, 8, and 10. or something like that. You're designing the experiment, and then you can see what the trend is for their grades. If they studied more and their grades went up, then it supports the hypotheses. You run it again. If your grades don't follow your hypotheses, say like you find out, well, 6 hours is actually the optimal time to study, then we should change our hypotheses, design a new experiment, and see what we can find from there. All right. So a couple other things we need to talk about with scientific method. If you accept your hypothesis repeatedly, what you do is you develop a theory. Okay, so theories are well-tested explanations for a broad set of observations. Okay, so here's the deal. If you make a theory, it's the theory is going to be an explanation of what's actually occurring. All right, it's not the observations themselves, it's your explanation for why you think that specific thing is happening. Okay, now theories, you can never actually prove a theory. All right, you can only disprove your theories. So, and that's kind of the idea, is you're going to develop a theory, and really a theory is just a hypothesis that's really well tested. Okay, so you start with hypotheses, you test it over and over again. As you start to refine your hypotheses, you can turn it into a theory, and then you continue to test your theory in different cases. All right, now, so you have theories, and then you have laws. Now, your laws are the statements of whatever is happening. So we have the law of gravity, what goes up must come down. Now the theory is, why does that happen? Is it gravitons? Is it something else? Is it little fairies that are pulling on little strings that we can't quite see yet? That kind of thing. Okay, so here we go. Which is a theory and which is a law? So when you heat a balloon, the gas inside expands. Okay, and then the gas expands because the molecules are moving faster. So when you heat a balloon, the gas expands. Well, this is a statement of what's being observed. So this guy here has to be the law. And this gas expands because the molecules are moving faster. This statement, this word here, because, is really what gives it away, that this is the theory. Because it's the explanation, right? It's the explanation of why this thing occurs, right? Alright, so that is, a couple more things, sorry. Common errors. So these are common things that affect our scientific experiments. So we don't want to let biasness affect your results. So, you might want to say, when we're doing our experiment with students and their grading habits, you're like, oh, I'm a student and I don't want to study more. So I'm going to, it might be that if you want to make the data say that the hours, spending more hours doesn't result in higher grades, then that might affect your data. Okay, you could also kind of go backwards, ignoring data that does not support your hypotheses. So if I was doing those, and I found out, oh, the person who studied 6 hours actually, did way better on the exam than the person who studied 10 hours, I'd be like, oh, that person was just a lot smarter. It doesn't really count. You just kind of ignore that point. Failure to consider error in your experiment. Always when you're looking at your experiments, try to find things that didn't quite go as planned, or maybe something that you didn't think of originally and you might have to refine it. And then equipment or conditions that are not adequate. So maybe your testing environment between the two groups wasn't quite good enough, or maybe the test wasn't big enough, maybe it wasn't over a long enough period of time to see what the actual results were, so on and so forth. So those are all things to consider when you're designing a scientific experiment. Paraffin paradox is something that we talked about in class. So come ask me in class sometime if you want to see it again. That's about it for Unit 1. I'll talk to you guys later.